Alright, welcome to the homework video for Chapter 1, Section 3 of Algebra 2. Again, here is your homework assignment. Now, the worksheet from class, you should have asked all your questions in class, so I'm not going to do any problems from that section. So if you still have questions on your worksheet, bring them in and get them asked and answered. Alright, so these are the problems that I'm actually going to work on. So make sure that you have your note sheets out and you're ready to go. Okay, so solve the following equation. So for me, when I solve, what you're going to see is you're going to see me put a division line down right there on the equal sign. Okay, the reason for that division bar is so that way I remember that if I do something to the left side of the equal sign, I'll have to do something to the right side of the equal sign. So if you need it, put it there. If you don't need it, ignore it. So, okay, again, what are the directions to ask? Are we solving, simplifying, or evaluating? We're solving. So what does that mean? It means to get the variable by itself. So which piece is our variable? Right, the W. So we want to get the W entirely by itself. So we're only going to look at the right-hand side. So from the right-hand side, what do we have to get rid of to get W by itself? So we go through our order of operations. We have no subtraction on the right. Do we have addition? Yeah. So we're going to subtract 5 from both sides. Remember, if I do it to the right side, I have to do it to the left side. It's going to be your -8, right? Same signs, add the two numbers. We're not touching the W. There's nothing underneath of it, so we just drop it down. And then 5 minus 5 is 0. So we don't have to put anything. Now, is our variable isolated? Yeah, there's nothing in front of it, nothing behind it, nothing under it. That's what I mean by isolated. So we're done. And there's your answer. All right, solve the following equation. So we're going to put our bar right down the middle here, down the equal sign. And then we're going to add in our crossbars as we need them to serve as equal signs. What do you notice? Where is the variable? Is it on the left side, the right side, or both? It's on both sides, and we can't work with things like that. We have to have our variable on one side. So that means that we either have to move the 6x or we have to move the 2x. Now we generally try to move the smaller piece. So what's smaller, 6x's or 2x's? Right, 2x's. So what's the sign in front of the 2x here? Remember, if nothing's written, it's a plus. So what's the opposite of plus? Right, your minus. Okay, so now we need one of our equal bars. We get that. So 6x's take away 2x's is 4x's. We have nothing here, so this is going to drop down. 2x's take away 2x's. These cancel and leave you with 0. So you're left with just the right-hand side of plus 59. Alright, so now this is just like every other problem we've done, right? We want to get the x by itself, so we know we have to move what first? Right, the plus 7. So we do that by subtraction. And then we finish off by actually doing the math. So plus 7 minus 7, this cancels. You get 4x equals 59 take away 7 is 52. Okay? Now, how do we get x by itself? Well, we've gone through subtraction. So now how do we get x by itself? We've gotten rid of subtraction and addition, so now we have to get rid of multiplication and division. So we have multiplication here. So what's the opposite of multiplication? Right, division. So we're going to divide both sides by 4. So what's 4 divided by 4? Right, those cancel off and become 1s. So we get x equals 52. 4 goes into that one, 12. So that's 13. So there is your answer. So x equals 13, and you're done. So just like what we did previously, only one extra step, and that is moving your x's so that they're on the same side of the equal sign. All right, and you should find that these problems get very repetitive because they're a lot of the same work. It's just that the order changes or there's one extra step, but the actual process is pretty much the same. So for this problem here, number 34. there's nothing to simplify on the left-hand side. So this is going to come down just the way it looks. Okay, but look at the right-hand side. Can we do anything to simplify that? Yeah, we can get rid of the parentheses, right, by using the distributive property. So what's 4 times d? 4d. And what's 4 times a positive 3? A positive 12. Okay, so now this problem is just like what we did on the previous screen. Okay? We have d's on both sides of the equal sign. That's not good for us. So we're going to move one set of d's. Which one's smaller? Right, the 4d. So we're going to subtract 4d from both sides. What's 5d? Take away 4d. Right, 1d. The plus 17 drops. These cancel and leaves us with 12. And this is just like what we've been doing from the very beginning. So we want to get d by itself. So we're looking at the left-hand side of the equal sign because that's where the variable is. Do we have any subtraction on the left-hand side? No. Do we have any addition? Yes, we do. So we're going to get rid of it. So this cancels. Leaves us with d equal to negative 5. Okay? Now, how do we know when to stop? When the variable is completely isolated. So that means nothing in front, nothing behind, and nothing underneath. Do we have an isolated variable here? Yes, we do. And we're done. Okay, so again, same basic process, one extra step. So when you're solving, your process is going to be simplify first. So simplify the left side, simplify the right side like we wound up doing here. Get your variables together. So we move the 4d from the right side to the left side so we only have one term with a variable, and then isolate that variable. So that's the process you're going to go through every time. Simplify, group your variable, isolate your variable. Okay? Okay, solve the following equation. Now, this is nothing new. It's just that it has fractions in it. Alright? So, real quick, we have to simplify first. So is there anything that can simplify on the left-hand side here? Yeah. What's the variable on the first term? T to the first power. What's the variable on the second term? T to the first power. So can we combine t's? Absolutely. But this is a fraction, and this is a fraction. So in order to add them, we have to have a common denominator. So I'm going to rewrite 1/2 so that it's something. I'm going to rewrite 1/3 so that it's another fraction, but these bottoms are going to be the same number. So if you don't remember how to do this, what you do is you multiply the denominators. So what's 2 times 3? All right, 6. So that's the new bottom. Okay, and then you do a crisscross. So you go 3 times 1. What does that get you? 3. And you go 2 times 1. And what does that get you? 2. So here you go. Now we have the same denominators, so we have a common denominator, and we can now add these. So what's 3 over 6 plus 2 over 6? Right, 5 over 6, because when you get a common denominator, all you do is add the tops. And there's still a t here. Okay, so now we're trying to get t by itself. So do we have anything being subtracted with t? No. Do we have anything being added with t? No. Do we have division? Technically, yes. Okay, and we have multiplication because we have a fraction, it's both. So what I'm going to show you is how we get rid of it. Whenever you have a fraction multiplied with your variable, all you do to isolate the variable is multiply by the reciprocal of the fraction. So that means that we're going to do this here. And remember, what we do to one side, we have to do to the other. So we're going to turn 10 into a fraction. So remember, any whole number can be written as a fraction over 1. And then we're going to multiply by the reciprocal of this fraction right here. So what is the reciprocal of 5 over 6? 6 over 5. And we're going to multiply that on both sides. Now, why we want to use the reciprocal is because what's 6 divided by 6? Well, those cancel off into 1s. And what's 5 divided by 5? Those cancel off into 1. So all we have is 1 times 1 over 1 times 1, which gives us 1t. So you notice that it isolates our variable for us, and that's what we're trying to get to. So now over here on the right, what's 10 times 6? Right, that's 60. All over 1 times 5, which is 5. But remember, for me, you have to reduce down the fraction if you can. And 60 over 5 I know can reduce because this ends in a 5 and that ends in a 0. So when you divide, you're going to get 12. And that is your final answer for t. Okay? So same basic process. Again, the only thing that changed is we know we're going to combine our t's, but in order to do that, we have to have the common denominator of 6. And then we just go through our order of operations all over again. So if you remember how to get the common denominator, these types of problems should not be that scary. So make sure that you take a look at the process and you keep working through it as you go through your homework. Okay, and if you still have questions, make sure you show up for after school tutoring, before school, after school, or see me in class, okay? Make sure that you get your questions asked and answered.